Good morning, everyone. Thanks for joining us this morning at our first Tech Talk of Millikan's at K Show 2025. I'm Tuğçe Aşıcı, and I am very happy to moderate this Tech Talk and welcome you here. In this Tech Talk, Jasper and Philippe, they will talk about how ExxonMobil and Millikan collaborated and how this collaboration resulted in a synergy that helps the automotive industry reach their recycled content targets and also be ready for the upcoming ELV regulations, end of life of vehicle regulations. First, let me introduce you to Jasper. Jasper has graduated from chemistry with a focus on analytical sciences from the University of Leuven in Belgium. And right after graduation, he has joined ExxonMobil, where he's gained extensive testing knowledge on flexibles in polyethylene and rigid packaging with polypropylene, as well as injection molding and extrusion technologies and processes. And since 2022, Jasper is with Customer and Application Development Group, and he is helping his customers achieve their sustainability targets by being an expert in mechanical recycling, and he is focusing on polypropylene, Vistamax, performance polymers, and exact polyolefin elastomers. So that's Jasper.
Thank you.
And here we have Philippe Scherling. He also is a graduate of University of Leuven. He has a PhD in chemistry, and prior to joining Millikan, he has worked in various technical, marketing, and business development roles at companies like ExxonMobil, also Jones Manville and the Beckard Group. And he joined Millikan in 2013, and there he gained extensive experience in automotive industry, electroconductive polymers, and fertilizers, very diverse expertise. And Philippe is now focusing on developing the EMEA market of our master batch solutions, where we increase the performance of polyolefins and improve the sustainability credentials. They will each give a short introduction of their companies, and then we will go through the content you've all been waiting for, and then at the end we have time for a Q&A session. So I hand it over to you.
Thank you. First of all, thank you for the great introduction. Thank you for the full Millikan team to host me here, to give ExxonMobil the opportunity to co-present with Millikan on this amazing booth and to show the innovative solution that we can offer in the recycling space when talking about automotive industry. Like Tuğçe mentioned, I will first talk a little bit what is ExxonMobil and what is the message that we want to bring from an ExxonMobil perspective this K 2025. So last year, October 2024, ExxonMobil decided to launch a new brand, ExxonMobil Signature Polymers, overarching all the different business units that are in contact with polymers. Think about polyethylene, the business unit that Tuğçe already mentioned. PVE stands for polypropylene, Vistamax, and exact. So the ExxonMobil Signature Polymers is really overarching this combination of different polymer brands. And the idea is, how can we put customer first? Customer is the priority, and it's really what can we do from an ExxonMobil perspective to put the customer at the first priority. And by this thought, we built 3 pillars. These pillars are partnership, innovation, and expertise. And we believe that with our very knowledgeable people working with us and with our innovative solutions, that we can offer solutions to the customers and to the value chain to really have the customers' value chain achieve their goals, what they want to achieve, especially now with regulation pushing us in certain directions. When we then focus a little bit more into the business unit that I'm supporting currently, it's PVE. So it's a global business unit focusing on polypropylene, Vistamax, and exact. So for polypropylene, we have a global and a regional offering into the market, from homopolymers going to random copolymers and impact copolymers. In Europe, we focus mainly on outstanding polymers, so not the commodity materials that we have everywhere, but really performance polymers that are really outstanding, giving a little bit more to the market than just a commodity homopolymer. And then we go into, let's say, the two number one products of our business units, with Vistamax for sure number one. Vistamax is a performance polymer, polypropylene based, and it's really being used as a kind of modifier to give performance to any kind of application. So Vistamax is really being versatile and can be used in a lot of different applications. If we then go to the start of this tech talk, Exact. So Exact is a ethylene-based material, so also known as a POE in the market. It goes hand in hand with Vistamax. So depending on the application you're looking for, it's either Vistamax can give a solution to you or either Exact. In this case, we went for Exact because we are talking automotive solution where you really need very low impact temperature performance. What Vistamax, because it's polypropylene based, cannot give you to the maximum. Exact is a little bit better from a chemistry aspect.
Thank you, Tuche, for the introduction. Thank you, Jasper, for the introduction to ExxonMobil. 3 slides on Milliken. We start off with a few numbers just to get everybody oriented on the size of the company. We're a global material science company. And when you look at 11,000 products, you can imagine that they go in a large variety of applications. We talk about medical, agriculture, consumer goods, automotive, of course, we're going to speak about today. And I'd like to invite you, maybe when you came here, you'll see the 3 LCD screens on the side, and you can tap these, and they give you examples from your day-to-day life where you touch Milliken products, probably every hour, maybe even every 10 minutes. Moving on, Milliken, since 160 years, we try to do what is right. And today, that means that we try to make this positive impact, not only today, but for generations to come. This must last in the future. We talk about sustainability. It came at us, it is here today, and it goes on, and it will continue to go on. And to do that, we partner with third-party companies, organizations, to help us to validate and also to advance our solutions. This makes us not really just an additive supplier. We are chemists. We are materials people. We have polymer science knowledge that we can leverage in making solutions, but we can't do that on our own. There are many examples on the right where you can see what we can do, and we partner for that with stakeholders along the value chain to put that in motion and to also realize that. And that is in fact the essential of the Tech Talk today. We partner with ExxonMobil, we chose to do that, to show you how really a very basic recycled polypropylene, as you know it, base case, can be elevated to meet specifications of automotive OEMs that are incredibly stringent.
Thank you. So indeed, as already mentioned, we have a market need. So whenever you discuss here on the K, also with customers, you see there is a market need. And that is really how can we do more with recycled material, incorporate recycling material, and that is all being pushed by regulation. So regulation is really pushing us to reduce, reuse, and recycle. So when you think about the packaging space, we have PPWR, so the packaging and packaging waste regulation. So that's really a regulation for single-use plastic to incorporate recycling. But now, automotive industry is also coming up with such a kind of regulation. That's called the ELV regulation, so end-of-life vehicle regulation. So here, the concept is very similar. The idea is you buy a car, you consume it over a couple of years, then these car parts are being recycled and reintegrated into the stream. So the idea is of this ELV regulation that by 2032, 20% of the car parts, on average, need to contain 20% of recycled material. Out of this 20%, 15% needs to come from end-of-life vehicle. So when you think of an example, it can be bumper to bumper or door panel to door panel, depend on the mechanical technical needs that you have. But there is always a but. The idea is here that we still have the very high mechanical performance that the auto industry has. Think about processability, that is directly linked to melt flow rate. Think about impact of performance, that is in this case notched impact performance at room temperature, but also at minus temperature. So that's why we partnered up, ExxonMobil, Milliken together in this case, and we thought, okay, in what kind of application our solution can be available. In this case, we can think about a front deflector, as seen here on the screen, but it can also be used in different kind of other applications. Think about bumpers, door panels. When you then go into the more technical part of the presentation, we see that the performance of the recycled stream that is currently present in the market is not meeting any of these regulations. You see the performance is rather low. With a value of 3.7, it's obviously not meeting the impact resistance at room temperature. That's why we start blending in exact modifier into this recycling stream at 20 and 25%. And you see 20% is already giving you an enormous boost. 25% is taking the next step. But what is most important, and that's also why we have this tech talk today, is that there is a synergetic effect between Delta Max and Exact. That's really clearly seen when you blend in 1.5% of Delta Max material into the Exact and into the recycled polypropylene. You go from a value around 22 and you start blending in Delta Max, then you go from a value from 22 to a value that is very close to 50. And that's the same trend is seen when you go to a 25% of Exact. So think about, you start from very low performance, around 4 impact performance at room temperature, and you could end up at a value at 60. So think about the jump that you make in terms of performance. And that's only at room temperature. As said before, we also have minus temperature, low temperature impact performance. In this case, we measured at minus 20 degrees. Depends on the automotive part, you need to go lower. If you talk about bumpers, probably need to go lower to minus 30, minus 35 to meet the requirements. But in this case, we have picked minus 20, just to keep it a little bit more general. Here also you see that the performance is really low. 2 is a very low value of impact. Here again, similar story. Exact, both doses, 20, 25%, is really boosting impact performance to more than double the value that it was at the beginning. And here we also see that Delta Max blending at a 1.5% ratio is really boosting even more the toughness performance. And this toughness performance is not only coming from the Exact, but majority is really coming from the Exact. But you can think now, okay, what is Delta Max then bringing to the table except for the synergetic effect? And on this, will Philippe a little comment.
Yeah, so until now, we added cost. We added very good performance modifiers, but we added cost. So now we need to reduce that cost again. And how do we do that? Well, you need good materials in the blend. You can think about, well, let me work on productivity. Because you know in automotive, productivity, the tax rate is very, very important. And that is exactly what Delta Max brings you in this synergy with Exact Plastomer. So where we have here, we talk about melt flow rate. And melt flow rate is productivity, is speed in injection molding. When we add Exact, we don't really change the melt flow rate. I mean, the grade has similar type of flow properties, must blend well with the polypropylene. So we have a good blend, and now we need to accelerate that, and that is going to drop my cost again. And I'm going to do that with Delta Max. Delta Max modifies and the flow, and at the same time, the compatibilization of the rubber phase, Exact, good low temperature impact, with the recycled polypropylene. That's what it's going to do. And we can do that with both the blends of 20 and 25%. And you see that we kind of double the MFR. And that is going to give you the cost reduction that you look for. Because you have to increase the recycled content. So you're stuck with that. You have to then improve the properties. And then you have to bring the productivity where it needs to be to compete with virgin material as much as possible for the economics. So you see in our story, in summary, the basic properties of the recycled polypropylene, very low, base grade, are the gray triangle. And we're going to expand that in terms of flow to the top. First blue, then green, and blue with the exact, and then green, the exact, and the delta max. And we're going to do that also for notch Sharpie, the impact properties, at room temperature and at low temperature. So we're not going to sacrifice one property for the other. We're going to use the synergy and expand the usability. And this is not only about a 20 and a 25%. You can do a 13% and 8%, depending on what type of part you need. You can do the formulation. We can help you. We have the expertise built up. But we wanted to show you really, stretch it to show what is all possible. So, in conclusion, we've spoken about exact POE and delta max to elevate the properties of recycled polypropylene to meet OEM standards. And we invite you to join us in exploring this solution real life.
Wonderful. Thank you. Thank you, Philippe. Thank you, Jasper. 5 minutes for questions.
It was clear during the presentation that the effect on impact and flow properties is really positive. You mentioned it in one of the slides that there may be a drop in stiffness. Can you elaborate on that? I mean, what should we expect for this property once you use these technologies?
Perfect. I can take that because indeed, when in this case, there is always a trade-off in properties. When you start blending in performance material modifiers into any kind of stream, is it recycling or is it virgin material, there is always a trade-off between properties. In this case, you add more rubber content. In this case, really a lot, 20-25%. So that means that the impact for performance comes from somewhere, and that's really the rubbery phase that you add. So that means that the impact is really lifted, but the stiffness goes down. So there the question is, what is the stiffness of your, let's say, starting material, and what is the threshold that you're looking for? In this case, like Philippe already mentioned, we went really extreme. So because we start at a really low quality, 100% recycled material. So to be able to push it to automotive standards, we had to go 20-25%. But it doesn't mean that you always need to use this kind of dosing. When you start using regular dosing, 5-10%, the stiffness will drop, but not significant. So then you are still within the boundaries that are allowed in the automotive industry.
One question. So you are modifying RPP.
Yes.
So what do you know about this PP stream? Is this a mono stream or is this from V streams? So what is the variety in this stream and how does it impact on your results?
So I'll take this one. The polypropylene we use came from a true recycler. Like we have not pulled it together from somewhere. So it is, let's say, a common uncontrolled stream, PCR based, if I'm not mistaken. Yeah, PCR based. So we're really talking about a base case product that you can buy at the minimum price in the market.
Thank you. For the automotive parts using this recycled polypropylene, can these parts be recycled again? I mean,
that is a very good question. So once Deltamax and Exact have, Deltamax is a reactive modifier. Once that reaction is finalized, the Exact is distributed in recycled polypropylene, and that's all stable. So you can, we did also, you can re-extrude it, re-inject it. So really the formulation is made like you would use a virgin, very high impact copolymer. And you can like take the bumper off, take the bottom plate off, and just recycle it in the same product without a problem. You can really recycle or re-inject it several times without degradation.
The question I have is on the regulatory aspect, particularly with now the the requirement is about 20%, as you said.
Yes.
But as and we are seeing this globally, that the regulatory aspect is increasing. And say if it goes to a 50% kind of recycled content, does the same kind of approach, and does, in terms of the mix, and does it still hold good in terms of cost, value that you can bring in equally with the quality of the impact as well?
I can take that question. I think there are a lot of, let's say, question marks in your question, because indeed it depends a little bit with the current economical situation. What is the cost of the recycling stream? Because if you go for a 50%, as you said, 50% recycling stream of already very high quality, yeah, probably that price is already way higher than a very base recycling material that we are showcasing here in this example. So that's also one unknown factor. And then, okay, you have a good quality recycling stream, but what are the performance? You have maybe a very clean recycling stream, but what are the performance related to automotive? Because this recycling stream can be perfectly used for injection molding items, but maybe not for very high toughness, impact resistance applications like a front bumper of a car. So that's all, yeah, a little bit uncertain. And I think as this ELV regulation is not yet in place, so it's on the table. It still need to have some signatures. But that's also taking into account that indeed it adds a little bit of the cost.
If I may top it off, what we are offering you today is in fact levers to pull. And you have an impact modifier. That impact modifier does something with Delta Max. Delta Max you can use more or less. The impact modifier too, you have to put in more recycled. I mean, is it going to be really low performance, medium, maybe better performance, the percentage? And that's the type of knowledge that both our companies have developed over the years, because we already presented something like this 3 years ago during K. And so certainly consult with us about that. But these levers help you to look at cost versus performance. And of course, it comes down to 0.5% at the end of the day. We know that.
So Jasper explained about the market needs, and also you explained about the synergy. But where exactly did the collaboration came from between both companies, Exxon and Milliken?
So when earlier on in the slides, and we explained that you can't reach these solutions alone. So collaboration, we already mentioned it 3 years ago during K. That was our big topic. And in this case, in fact, we see that the values that ExxonMobil is handling, are very similar to ours when we think about sustainability. And that is kind of why we came together. And it's more of a natural, I'm not going to say attraction, because that may sound funny, but it was a natural succession of events that brought us to work together on this subject. And at a certain point we said, now it's ready to publish, so let's make a tech talk out of it. But we share the same values for sustainability. That is in fact a major driver.
Great. Well, thank you all. Thank you for your active participation as well. Thank you, Jasper, Philippe. And we wish you a great day further.
Thank you.